Somewhere along the way in your life, you've been taught some method for simplifying square roots. And if I don't miss my guess, it probably looked something like this. You took this and you split it down. You said, okay, 40 is the same as 2 times 20, and 20 is the same as 2 times 10, and 10 is the same as 2 times 5. And then based on this, well, I can circle these, and these are boxed, and so then I'm going to juggle them in some weird way, and I'm going to end up with, I hate this method. I think it's really illogical, and I think it involves a lot of mental acrobatics that don't involve doing things that actually make sense. So, we're going to learn a new, simpler, much more straightforward way of simplifying square roots that'll hopefully make a lot of sense and make this whole process a lot simpler for you. If you've already mastered this way and you feel 100% comfortable with it, go for it, you're fine. But if you're open to learning something new, this could be really cool. This is all based around the idea that the square root of a times b is the same as the square root of a times the square root of b. And this is an important property, and we're going to look at proving it in the next video, but for right now, just roll with me. Square root of ab is the same as square root of a times the square root of b, which means that if I have a square root of some product, some composite number, that I can split it up into its component parts. That is really, really cool for this situation, because the square root of 40 has a perfect square right in it. You can see that the square root of 40 is the square root of 4 times the square root of 10. And this is exciting to me because we've already talked about the fact that the square root of 4 is 2, which means that all I have to do is rewrite this 2 instead of the square root of 4 times the square root of 10. So at no point did any magic happen. All I did was say 40 is the same thing as square root of 4 times square root of 10, and the square root of 4 is the same thing as 2. So square root of 40 is the same thing as 2 times the square root of 10. I'm just swapping things out for their exact equivalents. Same thing for 72. This one might be a little bit harder for us, and you might have a hard time figuring out what can come out of it and what can't. And if you're in a really good place, you might see, oh, 72 is actually just 2 times 36, and that's great. But if you're not in that really good place, that's okay. Just try to pull out any perfect square and see what happens. In this case, if I were to try to pull out the perfect square, 9. 9's a perfect square, and actually 7 and 2 add up to 9. I already know that that's going to work. So this is going to be the square root of 9, that perfect square that I kind of saw in there. And the square root of, well, 9 times what is 72? 9 times 8 is 72. And then I can rewrite this as 3 times the square root of 8. But then, hopefully, your brain is turned all the way on and you recognize, like, the square root of 8 has another perfect square inside of it. So I can rewrite this as 3 times the square root of 4 times the square root of 2. And so 3 times the square root of 4 times the square root of 2. One of these is a perfect square. 4 I can just swap out for its equivalent, the number 2. 3 times 2 times the square root of 2, which means this whole thing is 6 times the square root of 2. If you were on your toes, you would have seen that it didn't take 2 steps. You could have noticed right here that this actually can be rewritten as the square root of 36 times the square root of 2, and then the square root of 36 is a perfect square, so it's 6 times the square root of 2. It's to your advantage to try factoring out the biggest square you can first, and then working your way down. But even if you start with the smaller squares, like 9 and 4, you'll still get to the exact same place.